When our interest is to look at the relationship between quantitative variables, we cannot use other measures of association which are available to us. One of the very well-known measure of relationship is correlation. In this module, we will learn about the correlation. But before we talk about the correlation, it's important for us to understand the statistical relationship, which exists if a change in one variable x results in a systematic change, and that change could be increasing or decreasing in another variable y. We study the relationship of such types as relationship between height and weight, or one can be interested in looking at the relationship between height and age. There, special methods have been developed to discover the existence of statistical relationship between two variables. When we are looking at the relationship between two variables, we can talk about correlation or we can talk about association. When we talk about association, and these two terms are interchangeable, but generally in statistic nomenclature, we prefer using association term to represent the relationship between categorical variables, whereas a correlation to represent the relationship between quantitative variables. So when we have to look for the association, we perform contingency table analysis and related measures. But if our interest is to look at the relationship between two quantitative variables, then we look for the correlation. Correlation is of various types. It's defined as the Pearson's correlation and the Spearman's correlation. Correlation analysis involves various methods and techniques which are used for studying and measuring the extent of relationship between two variables. And performing a correlation analysis involves performing a scatter diagram, which is also known as a scatter plot, calculating coefficient of correlation, and testing for the significance of the correlation coefficient obtained from the sample. So the first step in correlation analysis is to look for a scatter diagram. Scatter diagram help us to pictorially represent the relationship between two variables. It's a plot where each pair of observations, x and y along two axes, are plotted, and the pattern of the resulting points revealing any correlation present or not. So if the relationship between the variable exists, then the points in the scatter diagram will show a tendency to cluster around a straight line or form some curve. So a scatter plot given by Chambers in 1983 reveals a relationship or association between two variables. It's a plot of values of y versus the corresponding values of x, where vertical axis, usually the response variable, is denoted by y, and the horizontal axis contains variable x, that is usually some variable we suspect may be related to the response. Here's a typical scatter plot, where we have the variable x and y, where x represents waist circumference in centimeters, and y represents deep abdominal AT area in centimeters squared. Here, each dot on this scatter plot represents a one value in x-axis and another value on the y-axis. Looking at this picture, it also shows us what's the trend of the relationship. Scatter plot can provide the answers to the following questions. Are variables x and y related? Are variables x and y linearly related? Are variables x and y non-linearly related? Does variation in y change depending on x? And lastly, are there outliers? Scatter can also be combined in multiple plots per page to help understand higher level structure in datasets with more than two variables. And such a scatter plot is called scatter plot matrix, which generates all pairwise scatter plots on a single page. The conditioning plot, also called co-plot or subset plot, generates scatter plot of y versus x dependent on the value of the third variable. Here is a quick picture for the scatter plot matrix, where we have four variables: potassium, lead, iron, and sulfur oxide in the population data, and we are looking at how they are related in this population data. Each graph in this scatter plot matrix represents a comparison of two variables. As the first graph here represents the relationship between potassium and lead. The second graph here represents the relationship between potassium and iron. Third graph represents the relationship between potassium and sulfur oxide. It also does other remaining pairwise comparisons too. This plot here represents the relationship between lead and iron. This represents the relationship between lead and sulfur oxide, and this one for sulfur oxide and iron. In a scatter plot matrix, the plots are symmetrically laid out, where the plots on the upper diagonal are the mirror images of the lower diagonal. Scatter diagram shows us whether there is a relationship or not, or whether there is an outlier or not. Here is a set of scatter plots which shows the various kind of pictures that depicts the various strengths of a relationship. Usually, if the values in a scatter plot are stacked together and they are very close towards each other, then the higher the correlation will be, higher the relationship will be. But if the observations are scattered far from each other, then the amount of relationship will be weaker. Like here in the graph A, it shows a perfect correlation. Whereas in plot D, that is a weaker relationship. Whereas plot B, plot F are showing a stronger relationship. Scatter diagram also help us to look for that whether the relationship is linear or non-linear, or it is monotonic or non-monotonic. If the graph shapes like this, it is linear as well as monotonic at the same time. But if the scatter plot looks like this, it is monotonic but non-linear. And this is non-monotonic and non-linear at the same time. Correlation is a measure of the degree to which any two variables vary together. In other words, two variables are said to be correlated if they tend to simultaneously vary in some direction. Correlation is a statistical tool which studies the relationship between two variables. Correlation is a linear association between two random variables. Correlation can be discussed as positive correlation, negative correlation, and no correlation. Positive correlation, if both the variables tend to increase or decrease together, the correlation is said to be direct or positive, which can be seen from the scatter plot with an example, the grade point average and hours spent studying. It clearly shows that if 0 is here, if grade point average is growing, the hours spent studying are growing too. And if you see this kind of relationship, it is called direct or positive correlation. Correlation can be negative correlation, where with the increase in the grade point average, there's a decrease in hours of video game played or vice versa. So here in this graph, if one variable tends to increase as the other variable decreases, the correlation is said to be negative or inverse. And thirdly, if there's no specific pattern visible from the scatter plot, it means that two variables do not follow the same or opposite trends together, which refers to the no correlation. Sometimes people mistake correlation with causation. It's very important to know that correlation does not imply causation. So it's very important that how we measure correlation, because statistical formulas will eventually gonna give us the results. But it's very important that we really understand by the theory or the physical phenomena that is this relationship can possibly happen or not. Some few examples that reflects that scatter plots are certainly not the ideal ones. They do have some problems. So one should be very careful while they interpret it. It is difficult to judge correlation strength by eye alone. Here are identical data plotted on different axes. First relationship seems weaker than the second. It is an artifact of the x-axis scaling. So we use a statistical method called the correlation coefficient to judge strength objectively. So the correlation coefficient is a measure of strength of relationship between two or more than two variables, which is denoted by R, and it is a dimensionless quantity that takes on values that range from -1 to +1. And a mathematical relationship does not necessarily mean that there is a correlation. When we calculate the correlation coefficient, it gives us the numerical values, and those numerical values ranges from -1 to +1. Here are some possible interpretations that we can obtain from the values, but one should be very clear that the sign of these values simply show the direction of the relationship. If the numeric value is closer to 1, that represents very strong correlation. And if the numeric value is closer to 0, that represents weaker correlation. And if it exactly equals to 0, it is negligible or no correlation. The positive values reflect the positive correlation, and negative values reflect negative correlation. Here are a few more interpretations of the correlation coefficient. Correlation coefficient can further be interpreted. Here we can see it with respect to the scatter plots and the possible values it can attain. Perfect correlation when r equals to 1 or r equals to -1. When r is equals to 1, it's reported as perfect positive correlation, and its scatter plot will be represented by a very strict straight line that is showing a positive relationship. Whereas if r is equal to -1, it's going to show us the perfect negative correlation. Again, a straight line, but in an inverse direction. If the value of the correlation coefficient is greater than 0.70 or it's less than -0.70, this reflects stronger correlation. If this value ranges between 0.3 to 0.7, it represents moderate correlation, and a weaker correlation if the values are less than 0.3 and closer to 0.